record on this computer. Okay, so let's just try everything to see if it's work. And then today, what we are going to do, we are going to start with the new unit about stack. Okay, so I will try to make it clear. And let's see. And you guys all know array, is it? You learned array, and array can be used to store a collection of items, so a group of items. And today we are going to learn a new concept. It's called stack, and we also call it a data structure. Okay, and general term it's abstract data type. So this is going to be our first time to learn data structure. Okay, so we are going to start with stack. So the concept of stack is, it's kind of like array, but it's not. Okay, it's not an array. The similarity between those two is stack is also used to store a collection of items, but it's an ordered collection of items. And why we see it's ordered later on, we are going to see, okay? And for stack, it's not like array. Array, you can access the item anywhere through like the index, is it? But for stack, you can only access the item at one end, and we call it top of the stack. So basically, if you view stack, you can view stack like a container, is it? And then you have items inside the container. But whenever you want to access the items, you can only access through the top. Is it? You cannot access the bottom unless you remove the top items. So that's a major difference, not like array. Array you can access anywhere, okay? So that's the general concept of stack. So I think the best way you can view it is like a container with only the top end opening, okay? And whenever you want to add a new item, then you add at the top. Whenever you want to remove, you also remove from the top. Okay, and so for stack, the main principle or the feature, or we call it manner, whatever, it's last in, first out. And you will see this in CS a lot. It's called LIFO. So that's the main feature of stack. So it's LIFO data structure. So last in, why we say it's last in? So whenever, because you add, you can only add at the top, is it? And regarding these three items, the top one is the last one you added. And first out, why we see that is this last item we added, whenever you remove, it's going to be the first, you move it out, is it? So that's the concept of stack. Okay, we can only access one, and it's always at the top. And, oh, I need to do, am I still on annotation? Why I cannot move to the next slide? Okay, so I'm not too good at the annotation, how to remove it. Let me try to do clear, is it? Where can I, okay, clear or draw, okay. Now I can clear off that. And so for our stack, we will start with the discussion about implement a stack. So basically, what we are going to explain it is how do we write a stack class? Then later on, you can use that stack class as a data structure for your data type. So we are going to start with to implement the stack using an array, okay? So it's going to be an array implemented. Because we are going to use an array, so let me kind of draw it, okay. So we have this container as a stack, and we have the items stored in our stack container. Because we are going to implement array, so basically we are going to use an array to represent all of the items. And using an array, then it involves with index, is it? So this is going to be index 0, is it? So the first item added in. And the second item added in is going to be index 1. So etc. for all of the remainings, is it? And so when we implement this stack, then we need an array itself. But like over here, this is the top item, is it? So for the top item, then when you use array, you need an index to remember the location of the top item, or we call it the position of the top item, is it? So that's why when we discuss implementation with array, the second item that we need to have it in our class is a integer top index. Okay, so that's going to be the basic two instance variable basically for our stack data structure. Okay, let me first clear the drawing. Clear the drawing. Okay, and then I will just directly move to the coding part. Okay, so over here, so we are going to define an integer. So we will start with an integer stack first, okay? And like I just explained, we are going to implement this stack using an array. And because this stack, we are going to use it to store integers, so the array type is also going to be integer. And like I also explained, we want also to remember where the top item is it? So we are also going to have an index to remember the location of the top item. And because it's array, so we also keep the array's capacity. And we have this as a constant. So that's why over here, it's the type is static final, okay. Okay, and I need to clear all of it again. Okay, and then next, we will discuss the stack. So for stack, the important operation regarding the stack is, so this we know, we learned for a class. It's a constructor, is it? And this is a default constructor. So for the default constructor, what it does is to create an empty stack. So this is empty stack. What empty stack is, it's a stack. There is nothing in it, is it? Because there is nothing in it, so that's why we put the index. That my top equals -1. So we set the index as -1. And the index basically in array, you cannot set it as -1. But here, we just want to use -1, this specific value to represent that this stack at this point is empty. Okay, so let's clear again. And then, so that's the default constructor. So the purpose is to create an empty stack. And the second constructor is constructor with explicit value. Is it in this case? It's another array. So for our stack, then in this scenario, it looks like, okay, you are going to have the stack, is it? And you're going to create with an existing array. So all of this part is from this P array. Okay, so that's what we are trying to achieve.
Excuse me.
Yeah, please.
What are we supposed to be seeing right now?
I'm muted.
What, you guys didn't see it?
We're still looking at the slides.
You are still, oh, I'm sorry. I just talked to myself. Oh, hold on. Okay, let me, oh, I just, hold on. How do I get back to the, that's interesting. Stop sharing. Oh, I moved to code. So, hold on. Oh, you guys are all, yeah, because this is my first time use it, and hold on. Oh, the share is still on the slides. Okay, sorry. How about now? Is it the NetBeans coding?
Yeah.
Okay. Yeah, I just talked a bunch on this coding. Okay. Okay, so you guys didn't see it. Okay, so let me start again, okay, regarding the coding part. So here we are going to discuss the stack implementation using a class, is it? And we are going to implement our stack using an array. And because we start our stack, the type as integer. So that's why our array type is also going to be an integer. So this is the first instance variable inside this stack class, okay? And the second instance variable regarding this stack is we call it mtop. So this is, the type is integer. So basically this is the index. And this index is used to remember where the top item is. So like this, so this is our stack, is that we have the first item, second item, the third item, is it? Because you're going to use, so all of these items is going to be in this array, okay? And because it's in this array, so I want to know where the top item is. So then in this case, the top item, where the position location is, I'm going to use this index. Okay, call it mtop. So then in this case, then the index is going to be 2. Is it because the index for the first one is going to be 0? This is the second one. So for the third one, then it's going to be 2. And this mtop index is going to remember where the top item is. So this is regarding the instance variable. And we also have this static final. And I think you all still remember this. So this capacity basically is a constant. So we're going to set the limit, the capacity of our array, the size as 8, okay? So that's our settings. And for the stack, the most important operations regarding stack is push and pop. So the push operation is whenever you add a new item at the top. So it's called push. Later on, I'm going to show the code, okay? So that's always add item at the top, because for stack, we just said it's a LIFO data structure. So you can only add at top. And whenever you want to remove, you can also only remove from top. So that operation is called pop operation, okay? So those are the two most important operations in stack. And for our implementation of the stack, we are going to start with our constructor, okay? So the constructor For this one, it's a default constructor. And for this default constructor, what it does is it's going to create an empty one. So basically, it's going to create an empty stack. There is nothing in it, is it? And then it's set the top index to -1. So basically, index cannot be negative, is it? But here we just use this mtop and set it to -1. Then we know, okay, this stack is empty. Because whenever you have a single item, if you have this item, this is going to be in your array, the sub-0, is it? So then in this case, then the top index going to be updated to 0, okay? So that's the empty stack. And the other very important thing in you create arrays, you need to call new, okay, to allocate memory heap to create a space for the array. So that's our default constructor. And then I still need to do the annotation and do clear. Oh, okay. Okay, and the second constructor, for this constructor, what it does is it's going to create our stack with some existing array. So basically this array is from this P array. Okay, you're going to create this stack with this existing array. That's what we are going to do in our second constructor, the explicit value one. So of course, the first is going to create an array, okay, heap. And the second thing is you are going to, you see this time the top index is going to be aligned with this existing array, okay? For existing array, in this case, it's 3 items. Is it the length is 3. So in this case, then the top index is going to be 2. Is it? So that's why M top is going to be set to 2, okay? And then the next part, what you're going to do is you're going to do element by element assign, okay, from P array to our newly created array, is it? And here we also have the try-catch block. The try-catch is in case like your existing array, you passed in, plugged in array, the capacity is beyond our capacity 8, then it's going to have exception. And it's going to generate the exception. The exception is going to be caught here. So this is our second constructor, and to create the stack with an existing one, okay? And the next most important operation, like I just said in stack, is push. Okay, so stack is LIFO operation, is a last in, first out. So whenever you want to add a new item, you add at top, is it? So how do we simulate this? And this operation, we call it push. Okay, so add a new item at top is called a push in stack, okay? So whenever we add a new item, very obvious, is it? The top index is going to be updated, is it? So it's going to be updated by 1. So that's why here we do mtop plus plus. And then you are going to assign whatever the item you dropped into the stack, is it, to the corresponding element for the array, okay? And of course, in this implementation, we consider this stack has certain capacity. So our stack in this case is bounded one. Okay, it's a bounded one. So that's why if it's beyond its capacity, it will cause this exception, okay? Okay, so that's the push operation. And then next, let's see the pop operation. for the pop operation, what it does, so we have this stack, is it? And in this case, the index, the top index is 2, is it? And you're going to remove the top item, is it? So I'm going to, oh, sorry, I shouldn't remove the container, okay. So the container is here, but I remove the top item, is it? After I remove the top item, then the top index is not going to be 2 anymore, is it? It's going to be 1, is it? So this is the top index. So that's why for the pop operation, what it does is it's going to decrement your top index by 1, is it? And of course, it shouldn't go beyond the empty of your stack index indication of the index. So that's why if it's -1, that you already empty the stack, you cannot empty more. That's why it's through this exemption and you catch this exception, okay? So this is regarding pop. So whatever the pop does when we do the implementation, we didn't do anything on the array itself. So basically array itself, the item is still there. What we did is just move the index, only update the index. The array, you cannot remove it. The array is still there, okay? But you just update the index. And with the updating of the index, then the stack know, okay, this item doesn't belong to the stack anymore. The stack will count from the index 1 and downward. Okay, so that's the second very important operation is regarding top. And the third important operation here is you want to also get the top item of the stack, is it? So this operation, we call it pop. And in our textbook, and also in Java library, we call it a pick operation. Okay, so the pick operation is used to retrieve the top item of the stack. And what it does is, if you take a look at the code is, basically it's just to return the top item from the array, is it? And of course, your stack shouldn't be empty. So that's why if the stack is empty, we're going to throw this exception, okay? So this is the top operation. So basically, we know the general important operation about a stack. So we learn constructor, and we learn the top operation, pop, and the push. Oh, and one other operation kind of important in our stack is we also need to have the to have the empty operation. So what this operation does is it's going to check if your stack is empty, is it? And the stack empty condition previously we said it's the index if the index is this -1. Okay, if it is a -1, then we know the stack is empty. So the major operation, push, pop, top, empty, and constructor, we know that. And a lot of time you also wanted to know all of the contents in your stack, is it? So for Java, we generally can also provide the toString method, is it? To override it. And what we did for our stack is we are going to output all of our contents of the stack from top to bottom, okay? So that's why when we do the loop, we loop from top to bottom and output all of the array contents as a string, okay? So we use the string concatenation and to output all of the stack contents and then return this string. Of course, if the string is empty, then we cannot do it, then in that case, we're just going to output an empty string, okay? And the next important operation here we discussed is a clone operation. The clone method over here, what we did is the clone. So you have this stack, is it? So you're going to have a copy of it. Is it? A copy of it, of course, the container should have all of its own copy of the items, is it? So in this regarding, we are going to do a deep copy, okay? So the deep clone. So that's why over here, and the good thing is for array support the clone, the deep copy of clone, is it? So we can just borrow it, we can just use the arrays deep copy. And of course, you're also going to set up this new stack's top index exactly the same as the existing one, okay? And you're also going to create this new stack, okay? And then you can return this newly created stack. See, this is the newly created stack, and you return it. Okay, so that's the implementation of our stack class. So over here, what we discuss is we create our own integer stack, and this integer stack implemented as an integer array. Okay, and this stack has limited capacity, so it's a bounded one. And next, let's take a look at how we use stack in our application. Okay, so for our second Java file, so this is, we call it a driver file, okay? And in our driver file, what we did is you need to first call new stack, okay, to create our integer stack. And over here, we have an array. So this is our array. And what we want to fill our stack. So this is that first stack. Is it? It's empty initially. And then we are going to try to push like 29, 51, 308. So all of those numbers one by one into this stack. Is it? And then after we finish filling our stack, we're going to output our stack. Okay, so that's the first part. And let me run it and see the output. So is it, so did you see this is our first stack we fill with all the numbers. And you can also see, is it, it's, so the stack grow, the stack can grow, grow upward, is it? So here is the bottom, is it bottom? So basically the bottom is at index 0, is it? And 99 is the last added, but it's at the top, okay. Oh, no, not to save, I don't need to save. I just needed to clear, okay. Okay, so that's the first part. We run our stack, we call push operation, okay. And then next, let's see, because our stack capacity is 8, we already filled with 8 items, is it? And I want to add another one, 1000. And can we add it in this case? Did you see that index out of bound? Exception is thrown, is it? Because 1000, because our stack already full, so you cannot add any new item, okay. And annotation, oh no, I don't need to go to annotation. So over here, we showed our stack is a bounded stack, and if you want to add a new item, when stack is full, you are not going to be allowed. The exception is going to be thrown, is it? Okay, and then what's the next part? The does is we are going to call the clone function. Is it to call the clone? So we create a copy of our stack, and then we pop the top item out. And then we are going to check, okay, this item is popped from the original one or the clone one. Is it? So we have this is original. Is it? This is the clone. And we pop item. We pop it out of the clone. So the original shouldn't be impacted anyway, is it? So let's check if it does all of that. And we run it. So this after stack is full, the stack is this, is it? And over here, we say after removing the top item of the clone, the original stack, did you see 99 is still there? So it didn't get impacted, is it? So that's why we say, okay, our clone function is a deep copy one, so it won't impact our original one. So it achieves the purpose, okay? And what the next part shows is with one of the very important useful application for stack is it's very nice to do reversing work for you. Okay, so here let's see. So we have a second array created. For this second array, what it takes is it take off the items from the stack. So for the stack, it keep doing top and pop. So it use the top to get off the items from the stack and assign it to the corresponding elements in the array, and then it does the pop, okay, pop of the items out. And after that, we are going to enter array 2. We should, yeah, after that, we are going to output this array. Is it? So from the beginning to the end, then we are going to see basically the array is reversed. Okay, reverse. So let's take a look the running result. Did you see when after we do the top and the pop with our original array, this is our original array, is it? And the items. So the original array, not the original stack. This is the stack. So here is the top and the bottom. So top and the bottom, is it? And when we call, so what we did in that loop, in the loop, what we do is top and pop repeatedly, is it? So what we get for our second array, if you take a look at the output, is it? So it's reverse the order of the original array. Because our original array is 29 to 99. Okay, so after we keep calling top and pop within the loop, what we have is a reversed version of the original array. So here, what is the point to try to see is stack is quite useful for reversing work. Okay, and I think the important information for our first class, we kind of get it completed. And I think that's all